This is the circle question from 2009 in paper 2. So it's question 1C. And the question that was asked was if you've got two circles intersecting at the points P and Q. P is given by 2, 0, Q is defined to minus 2, 8. And if the distance of the common chord, which is here, from each centre is root 20, let's put in that. That distance on both sides is root 20. We need to find the equation of each circle. So we're looking for the equation of these two circles. The first thing to do here is to, I suppose, when you don't know the equation of a circle centre, you just call it the general point minus g minus f, which fits into the general circle formula. So we just call it minus g minus f. We just focus on one circle because that, in often these kind of questions, that gives you two answers, and of course the other answer will be the answer for the second circle. So we'll just focus on one. A good tip in any circle question is to, even when you're not asked, to fill in any missing radius. So there's certainly a radius from here to here. And let's see if that will help us. And a few things we can do here. It should be obvious that the midpoint of the common chord is on the line joining the centres. So if we can get that point, and we get that using the midpoint formula, and the midpoint formula is x1 plus x2, which is 2 minus 2 over 2, y1 plus y2, which is 0 plus 8 over 2. So that's the midpoint, and that gives us 0.04. So now we have that point as well, that's the 0.04. And in the next part of the question is really, I suppose, some of our theory from the line and some of our formulas from the line. A few things we can do here. For example, the point here, 2, 0, if that was on a line, we put it into the line for that equation. So if it's on a circle, we put it into the circle equation. Now, when we don't know a circle, the general circle equation is x squared plus y squared plus 2gx plus 2fy plus c equals 0. And if you put in the point 2, 0, that means that you get 2 squared, 2 zeros on the circle, so you can put in 2 for x, 2 squared plus 0 squared plus 2gx, which is 2g into 2 plus 2fy, which is 2f into 0 plus c equals 0. 2 squared is 4, so that gives us 4 plus 4g plus c equals 0. There's our first equation. Now we do the same for the point minus 2, 8, because that's also on the circle. Again, as I said, we're just dealing with one circle. Forget the second circle for the moment, because if we just deal with one circle, we'll find we get two answers which correspond to the two circles in the diagram. So just focus on the circle on the left. Minus 2, 8 is on that circle also. So if you have minus 2, 8, that gives us fill out the formula also, and you get minus 2 squared plus y squared, that's x squared, we're using this formula up here, plus y squared, which is 8 squared, plus 2gx that's 2g into minus 2 plus 2fy, actually, and for y of course we put in 8, plus c equals 0. And we tidy that up a little bit. 2 squared is 4, minus 2 squared is plus 4. 8 squared is 64, so we've got 64 and 4 is 68. Minus 4g plus 16f plus c equals 0. And again, good practice, that's as far as you can go with any equation. With a box around it, then we can go no further. Okay, so that's the second equation. You might guess at this stage we're aiming towards 3 simultaneous equations in 3 unknowns, G, F and C. And that's very often the case with the circle part C question. This would be a typical circle part C question, where you're given 3 pieces of information about a circle. You put the 3 pieces of information into the equation here, and that gives you 3 simultaneous equations in G, F and C, which you then solve to get G, F and C. And once you have G, F and C, of course, you have your circle. And that's the approach here. We've got our first simultaneous equation, now we've got our second one, so we need one more. So we need to use the final piece of information that we were given. And the piece of information that we haven't used yet is this distance here, the distance root 20 between minus g minus f and 0, 4. That's the distance formula. So if we use the distance formula, do that. So the distance formula tells us that the distance, let's say between 0, 4 and minus g minus f is root 20. So root 20 is equal to the root of distance formula is x1, x2 minus x1 to be squared. So we'll say minus g minus 0 to be squared plus y1 minus y2 to be squared, which is minus f minus 4 to be squared. And of course, square both sides, get rid of the roots, and we get 20 is equal to minus g squared, which is plus g squared. And you take out the minus here, minus squared is plus anyway, so that becomes f plus 4 to be squared. And there's our third and final simultaneous equation. And the rest of the question then is a matter of just algebra really. It's the circle part of the question is over now. It's just solving 3 simultaneous equations. And you know, that would involve well, the easy thing to do is actually eliminate C from these two if we just label them 1, 2 and 3. The way you can go about this, it seems to me here at the moment, the easiest way would be just to subtract those two, and that gives you the C straight away, which means we don't have an equation in just G and F, and we also have an equation in G and F down here, and the rest then should be straightforward algebra. The squared in the G and F here would indicate that we'll get 2 answers, we'll get a quadratic at some stage, which is what we expect, because after all there are 2 circles involved. So without finishing off the question, I think the remaining steps should be straightforward. Just to remind you again, we just solve equation 1 and 2. To get rid of C. And that gives you just 2 simultaneous equations then. So whatever result you get, you take it with equation 3 here then. 2 simultaneous equations, you get a quadratic, which gives you two answers, and each answer corresponds to a circle.